Okay, what is the value of k from the C problem according to the previous class? What did you have?
For C, I got
Okay, let's try it right now. Okay. Okay, so given that the raffle is a fair game, right? In the fourth week, we have to find the value of k. Okay, and this is our table of price, right? All right, and the probability of get zero price is 9p, right? But what is the value of p? 120. So the probability of getting this price is turns out to be 9/20. Okay. So to receive this price, 20 bucks, it turns out to be 7/20, right? And the grand prize will be 4/20, which is 1/5. And raffle ticket weekly raffle ticket course is k. Okay, we have three different price: $0, $20, and grand prize. How come can we have grand prize? The grand prize is $100, right? And increase by $5 every week. So in the fourth week, what is the grand prize in the fourth week?
It would be well, if nobody gets it, it would be $115.
$115. Yes. Okay, the first week is 100, right? The first week is 100. The second week is going to be, $115 in the fourth week. Okay, so it turns out to be $115 in the fourth week here. Now, when it's come to fair game, the expected value must be 0. But how can we find the expected value from? Let me write down here. How to find the expected value of gain from this game? Now, okay. So let's find out. Okay, k is the cost. How to have gain? It's gonna be price minus cost, right?
Yeah.
Price minus cost is price. The first one is 0, so it's gonna be 0 minus cost times its probability, 9/20, plus the next one is 20 minus k, right? Times its probability, plus grand prize is 115 minus k times 4/20. Okay. Just like this. But when it comes to fair game, the probability must be 0. Alright? So this term must be 0. Okay? Then we have to solve for k from this equation. Okay? Can you solve this equation with me? Solve for k. Okay?
Wait, I need to grab my graphing calculator. Whoops.
Graphing calculator.
Yeah.
Oh. Okay.
Okay.
Okay, just distribute each value into the bracket and calculate, right? Calculate the like terms and solve for k. So what is k right now?
K is 30.
Yes, k is 30. Okay, k is 30. So the price, the cost of raffle ticket is 30. Okay, very expensive, right? Okay, it's quite expensive. Now, I want you to try to do the deep problem yourself. Okay, I want you to find the week in which the expected profit for the ticket is $5.
Okay.
Okay, find the week. Right. So now let's go to binomial theorem. Here, you want to draw the graph of binomial distribution, right? Okay, now, do you have this file here? Because the first problem has 9 questions. Okay. Now, take a look at this. We have variable x, which is binomial distributed with the number of trial of 6, and the success probability is 0.9. Okay. Try to do the first 5 questions. So what is the probability of x being 4? X being 4. Okay.
Okay.
It's going to be 6 choose 4 times 0.29 raised to the 4 times 71 over 2, right? Okay. Okay, give me a second. Okay, the number of trial. You got 0.053, right? The trial is 6. The success probably is 0.29. Okay. So it is 0.0535, right? Okay. You want to have 4 digits. Now what about the second one? Here. The probability of x less than or equal to 4.
You have to do CDF.
Yeah, it's gonna be CDF, right? Okay. So what is that CDF? Okay. So it's gonna be, for me, it's gonna be 0.9372 here. Plus this value. Okay, plus this value is gonna be 0.0535, which is 0.9. 0.9 and what? Let me try to calculate. Okay, 5, 3, 5, 7. So it's gonna be 907. Okay, very good. We got it. Yeah. And what about this one? The probability of x greater than or equal to 1 less than 4. How can we calculate this one? Here.
We need to find the probability of 1 and then the probability of 4.
Yes. But is x greater than or equal to 1 and less than 4? Can we deal with that? So it's going to be
Well, 1 is going to be and then
0.442. Is it for x less than 4? Minus which one? Here.
oh, it's going to be the bigger one minus the
So minus probability of x less than 1, right? Right? Okay. So the probability of x less than 4 and less than 1 is going to be p of x less than 4 minus the probability of x less than 1 is going to be 0. Okay? Because the least one is 0. So it turns out to be 0.937
But isn't it equal to 1?
less than 1.
Less than or
Yeah.
equal to though?
So what is this interval? X must contain 1, right?
Yeah.
But less than 4. Okay. If you look at the real number line, look at the real number line. This is 1, this is 4, right? But we want to have this interval containing 1 but less than 4. Okay. Now, what do we have? I want to start with less than 4. All number that is less than 4. Okay. All number that is less than 4. But I want to erase this segment containing 1. Once you erase this segment, it must have 1. You have to erase by this line less than 1, right? Can you imagine?
Yeah.
So this line is going to be less than 4. This line is less than 1. Okay. So the probability of x less than 1 is going to be the probability of x less equal to 0. Right?
Mm-hmm.
Because the number of trial cannot be negative. Okay?
Okay.
The least one is 0. So what is the probability of 0? It's going to be okay. If I calculate this myself, it's going to be 6 choose 0, right? 0.29 raised to 0 and 0.71 raised to 6 minus 0.71 raised to the 6, right? Okay, 0.71 raised to the 6 turns out to be 0.937. If I use 3 digits, it's going to be 0.128. And you calculate this number, right? It's going to be 0.809. Okay,
Okay.
that's it. Now, what is the probability of x greater than or equal to 0? Now it's greater than. What is this one, Sarah? To calculate. 0.76. How do you have 0.763?
I did binom CDF.
Binomial
Binomial CDF.
CDF, right?
Yeah.
But it's greater than or equal to 2. So it's going to be 1 minus probability of x less than 2, right?
Yeah.
Okay. One that is less than 2 is going to be, what is this probability? Less than 2. Mine is 0.442. Going to my calculation. Here. According to Wolfram Alpha. Two. Point 321. Oh. Point 321. So what we have is the probability of x equal to 2 is 0.321, right? This is just equal, but what are the probability of x less than 2? Less than 2. Less than 2 is equivalent to 1 minus x less than or equal to 1. Okay? Right? Less than 2 is equivalent to less than or equal to 1. Okay. So it's going to be 0.558. Okay. 558. Okay, number 5. Here. The probability of x less than or equal to 4, given that x is greater than or equal to 2. How can we calculate this? This is the given probability, right? To do this.
We need to calculate x 4 first.
So, okay. So, how to calculate this one? Conditional probability, right? Conditional probability is probability of x less than or equal to 4, given that x greater than or equal to 2. Okay. Okay, share your screen.
Yep.
Right, we got this. So, according to this formula, conditional probability, what is this probability? What is it?
I need to find.
So according to conditional probability formula, okay, what is the numerator?
And then
Just kidding.
the numerator would be, well,
You mean 0.991? Alright, the numerator is going to be x less than 4. Okay? Intersection x greater than or equal to 2. Okay? What is intersection? Intersection is and, right? This is and. Okay, intersection is equivalent to and. Union is equivalent to or. Okay. Now, and we have this numerator. So what is the denominator? Denominator is going to be this probability. X greater than or equal to 2. Alright? So, what does it mean by this one? I have the number that is less than or equal to 2 and greater than or equal to, less than or equal to 4 and greater than or equal to 2. What is this?
It could be PA plus PB. Well,
Or you PA plus PB.
minus PA and PB, but we don't know what the.
Okay. This one is the probability of A union B, right? This is the probability of A union B. Okay, now, if I say I have less than 4 baht and more than or too much. What do you mean? Is that 3? Okay, it's gonna be like this. It's gonna be x greater than or equal to 2, less than or equal to 4. Okay, right? This inequality is read as x greater than or equal to 2 and less than or equal to 4. Okay, greater than or equal to 2 and less than or equal to 4. Okay, it's going to be equal to this one divided by the probability of x greater than or equal to 2. Alright, now let's calculate this numerator here. So how do we have this numerator? Here. This is going to be the probability of x less than or equal to 4 minus the probability of x less than 2, right? Divided by the probability of x greater than or equal to 2. Write it down in terms of CDF. Okay, try to write this down in terms of CDF. What is this probability? What is this?
Oh, it would be 0.558.
0.55. Okay, it's gonna be 1 minus probability of x less than 2, right? Okay, let's go. For this one, I think we have this term already, which is 0.991, right?
Yeah.
0.991 minus the probability of less than 2. Where's less than 2? Less than 2 is point, okay, 0.442 divided by greater than or equal to 2, which is 0.558. Okay, then we calculate. Okay, calculate this one. Calculate this one. Okay, 0.991 minus 0.442. This is going to be 0.549 divided by 0.558, which is divided by 0.558. Okay, now use your calculator.
.984.
Yes, 0.984. Okay, 0.984. Good. Now, number 6. Number 6. Okay. Use your answer. Okay, use your answer in number 5 to determine whether x less than or equal to 4 and greater than or equal to 2 are independent even. So how can we do with this?
You need to do the independent event formula, which is
A intersect B equal to the probability of A equal to the probability of B, right? Okay, this is so A and B, even A and even B are said to be independent events. Okay. And only if the probability of A intersect B equal to the probability of A times the probability of B. Now, my question is, what is the probability of A less than or equal to 4 and intersection X greater than or equal to 2?
0.549.
0.549, right? Maybe in the numerator, okay, is 0.549. Now, what about its product? X less than or equal to 4 times probability of X greater than or equal to 2. This product, you got one, right?
0.4. Oh, 0.549. No. 0.44488.
Okay, X greater than 2 is going to be 0.558. Let's calculate this one. So it's going to be 0.991, 0.558, right? So it's going to be 0.553. It's not equal.
Yes.
Okay, it's not equal. So we can see that the probability of X less than or equal to 4 and X greater than or equal to 2 is not equal to X less than or equal to 4 times the probability of X greater than 2. Okay, so they are independent. They are independent. All right, now what is the expected value of X when X is binomially distributed with a trial? The number of trial is 6 and the probability of success is 0.9. Okay, 6 and 0.29. So it's going to be 6 times 0.29, right? The number of trial times the probability. Okay, it's going to be 0.29 times 6 is 1.74. Next is variance. So how to find the variance? Variance. It's going to be the number of trial times the success probability times the failure probability, right? Okay, so it's going to be 1.74 times 0.71. Calculate. Okay, what is that number? It's going to be 1.235. Okay. Alright, the last one. Draw the graph of distribution of X. So how to draw it? Draw it. So now we know that X is binomially distributed with the number of trial is 6, right? And the probability is 0.29. Okay. Is that a bell-shaped curve? Is that the bell-shaped curve?
sorry, that
shape.
was my Gmail.
Okay. When x is binomially distributed, x is going to be discrete variable. Okay. X is going to be discrete variable. So the graph is not going to be a curve like that. It's going to look like bar chart because what are all possible value of x? It can be 0, 1, 2, 3, 4, 5, and 6, right?
Yes.
Okay. Then what you need to do is to calculate the probability of x equal to 0. Okay. Probability of x equal to 1. The probability of x equal to 2. And the probability of x equal to 3. All the way to the last one. The probability of x equal to 4. The probability of x equal to 5. And the last one, probability of x equal to 6. Okay. Okay, let's write down the plots here. So this one here, so we have 0, 1, 2, 3, 4, 5, and 6. Okay, this is trial number 0, 1, 2, 3, 4, 5, 6. Okay, and the vertical axis is going to be probability. Probability. Okay, you're calculating. What is your calculator?
Here.
I mean, what is the model?
TI-84.
GR84.
TI-84.
GI.
Yes.
GI84, like this. Seems to be expensive.
Yeah, my school makes us get it.
How much is it?
It's like $100.
$8. Oh, I thought it's gonna be 10,000 baht.
No.
It's just $100.
Yeah.
Okay. Okay, you're calculating very fast. Okay, got when x equal to 0, the number of trial is 6. Okay, mine is 0.128. The probability is going to be 0.128, right? When x is 1, the probability is going to be 0.314. Okay, when x is 2, the probability is 0.321. When x is 3, the probability is 0.175. Okay, and when x is 4, is 0.053. When x is 5, now the probability is 0.009. When x is 6, and x is 6 is going to be it's very low. 0, 0, 1. The highest probability is 0.321, right?
Mm-hmm.
So we have 1, 2, 3, 4, 5, 6, 7. Okay. So we got the highest one is here. So it's going to be 0.35, 0.30, 0.25, 0.20, 0.15, 0.10, and 0.05. Okay. So the probability of x equal to 0 is 0.128. So it's going to be somewhere here. Okay, like this bar. Right. The probability of x equal to 1 is 0.314. 314 is somewhere here, right? Here. And the probability of x equal to 2 is 0.321. It's a little bit higher. So it's here. Okay. And the probability of 3 is 0.0175. Here. And the probability of x equal to 4. 0.053. Okay. It's very low here. The probability of 5 is very small, 0.09, right?
Mm-hmm.
0.6 is very low. Yeah. It's something like this.
Mm-hmm.
And here's a graph of probability distribution. Okay. But you don't have to draw. You don't have to draw the curve. You don't have to do this.
Okay.
Because binomially distributed random variable is discrete. Okay. Alright, so how do you think of the first problem?
That's good. Thank you.
Yes. Okay, can you try to do problem 2? Can you?
Yes, I can do
Problem
that.
2. Okay, I think you can do that. It's very similar to the first one, the third one, and the fourth one. Okay.
Thank you.
Right. So, do you speak Thai, Sarah?
Yes, I do.
Okay, which one do you prefer?
I prefer English.
Okay, you prefer English. So English is your first language.
Yeah.
So how do you learn to speak Thai?
My mom.
Your mom speaks Thai.
Yes.
So who speak English in your house?
My dad.
Dad.
Mm-hmm.
All right. So what do you want to do next, Sarah?
Do you have another class, right?
Yes, another class.
Okay. Then I'll send you the time for. I'll see when I'm free next.
So it's not gonna be always Sunday, right?
Yeah.
Oh, okay.
Wait, I think next Sunday. Yeah, I think it's Sunday next week.
You think it's Sunday next week? So what is it? What is the topic?
I will let you know.
Okay, let
Okay.
me know. Okay.
Thank you.
Okay, that's it for today. Bye bye.
Bye.